So here we go. So this is a lesson DL4. Okay, and you'll want to do the homework for DL3 before you do the homework for DL4. And if you haven't watched the video for DL3, DL4 is going to seem a little quick. Okay, but I'll still try to go slow. Okay, so I'm going to put graph paper. So make sure you have your notes so you could do this. This is going to be a continued. Oh, probably I'm not in a good spot. Okay, so let me spell that better. Okay, so this is a continued graphing of radicals. Okay, so there's two categories. So put a line directly down the middle of your paper. Okay, and there's going to be two categories of this. There's going to be the even radicals, and there's going to be the odd radicals. And yesterday we did one example of an even radical, and we did one example of an odd radical. That is interesting about the, oh, don't I have my notifications turned off? Do not disturb. Oh, okay. Sorry, let's go back here. So, yeah, the captions. Oh, do you, Charlize, on those captions, is that each student would put the caption button? Or do I put the caption button? So the student does it. Charlize, not me. Perfect. Okay. I wonder how well I say my words to see if they are the same word. That's kind of cool. Okay, I'll try not to write too close to the bottom in case the captions are there. Okay. Okay, so even radicals and odd radicals. Okay, so an even radical would be if in the square root sign, you have an even number in the corner. Okay, so an even number in the corner like 4. So an odd radical is going to be if you have an odd number in the corner. Now we did 2 yesterday. We did cube roots yesterday. Or not yesterday, Tuesday. And then we also did square roots. But square roots, usually they don't put a number in the corner. So I'm going to put right here, square root of x, and I'm going to put the 2 in the corner. Okay, but usually people don't put the 2 in the corner of square roots. They just know that you need to have pairs of 2. Okay. So any odd radical problems are going to behave the same way, actually. 7th root of x. And any even radical problems are going to behave the same way. Okay, so let me show you what table we're going to use for both of them. I like to use the same table if I can for problems that are in the same chapter, because when you have to memorize different tables, sometimes you switch them around. Okay, and for those of you who weren't here on Thursday or haven't watched the video yet, the radical graphing is okay if you forgot it by Algebra 2, but what I want to use our new radical graphing as is reminders of moving it up and right and left and down and all those things. And so we're going to remind ourselves of the transformations using this new graph. Okay, and we're all done with chapter 9, which is really important, which was quadratic, and the other classes are working on chapter 9. Okay, because that's one of the most important chapters in the book. Okay, so XY. So in both cases, you're going to pick -1, 0, and 1, and then put a line. Okay, put a line after that. So -1, 0, 1, you're going to pick for the odds and the evens. And then the fourth number, you're going to pick 2 to the corner number. So we'll put corner, 2 to the corner. Okay, and the same thing here. So you're going to do 2 to the corner. Now the corner number actually has a name. So maybe we should write it over here. We can write it over here on the right. This, if you put an n in the corner, this n is called the index. This is the corner number. Okay, it's called the index of the radical. Okay, so we're going to basically put 2 to the corner number, and then we're going to also put the opposite sign. Oh, that's weird. My pen's acting weird. Okay, so we're going to put also the opposite of that one. What's interesting about these radicals, and I always substitute them in, okay? But if you do the fourth root, say we're doing the fourth root one, if I'm doing the fourth root of -1, that means I'm looking for 4 numbers that multiply to be -1. But 4 numbers don't multiply to be -1. So there's nothing that works here. So I put no. With square roots specifically, square root of -1 is I. That's an algebra 2 concept. This is an I right here. A little rounded I for imaginary number. Oops. And remember, I told you it was good for engineering. So this is -1. Oops, that's not -1. Try that again. So this is I in algebra 2. We called it not real, which means you can't graph it. But it turns out that whatever even number was in the corner, you're never able to do the -1. So you put no. Now the fourth root of 0 is you have 4 numbers multiplying to be 0. So you know that's 0. And the fourth root of 1 is you're multiplying 4 numbers and trying to get 1, and that's 1. So these tables will look very similar, but go through the process of the thinking, because you're not going to be able to memorize it. You're not going to take a test. You're not going to take any quizzes. So what you're, and regardless, even if you didn't have tests and quizzes, I would still do the same thing, is practice them so that when it comes up, you remember what numbers to substitute in, but you don't have to memorize the X and the Y values. Especially if you memorize them a little backwards, then you get the wrong answer. Okay, now let's just compare the -1, 0, and 1 with the odd ones. Okay, so I'm writing to the right side now. So let's pretend we're doing the 5th root of X. Okay, so we're going to do the 5th root of X on the right side. Okay, so on the right side, if I wanted the 5th root of -1, that means I need 5 numbers. Oops. I need 5 numbers that multiply to be -1. Well, that'll work, right? Can't I have 5 -1s? We were talking about this yesterday, so it was with a cube root. Well, if there's an odd number of negatives is negative when you're multiplying. So this one's possible, so you don't put no. So that's why the odd radicals turn out to be a different shape than the even radicals. Okay, and then the 5th root of 0 means you're looking for what? 5 of them to be 0, so that's 0. And then 5th root of 1, I need 5 of them to be 1, so that's 1. Okay, so for all of them, the evens, the table looks like the left, and for the odd ones, it looks like the right, but don't memorize it. Okay, actually substitute it in, and it'll help you practice your radicals as well. Okay, now the hard part of this is knowing what to pick. So what you pick, I'm going to change this to red, is the 4th number is different depending on the problem. So what you do is you do 2, always 2 to the power of the corner number. Okay, so this number, you're going to pick 2 to the power of the corner number. There we go. So you could see it. So that's, yeah, you could see the 2 to the 4th. Not very good, though. I don't know why it doesn't show up well in the corner. Let me move it over. So 2 to the power of 4. Yeah, that's better. Okay, now 2 to the power of 4, you're going to work that out by doing 2. You know, my tablet's not too happy with working at the bottom, so I'll write up here a little. I think it's not very good at working on the corners. So 2 times 2 times 2 times 2 is 16. So that's the number I'm going to pick here. And then I'm also going to pick -16. But if the answer was no for the first one, the answer is also going to be no for the last one. But I kind of like having 5 numbers, even if 2 of them say no. Okay, and then what is the 4th root of 16? I need 4 numbers that multiply to be 16. So type in the chat answer what number that would be. So what times what times what times what, all the same number would give you 16. And the answer is 2. Yep, so 2 would be this answer. And it actually always looks like that because we pick the 2 to the 4th number. Okay, now what happens? Let's look at the odd radicals. So that would be 2 to the corner number. So what corner number in this problem is it? 2 to the 5th. So let me figure out what 2 to the 5th is. 2 times 2 times 2 times 2 times 2. I don't like multiplying all the 2's like that. I kind of multiply them in groups. So I multiply 8 times 4, which is 32, like a reverse tree. Okay, so I pick 32 and then I pick negative 32. Now, was the top number no on the odd radicals? It wasn't. So that means both of these are going to work out. So 5th root of 32 and the 5th root of negative 32 are both going to give me values. The odds don't have any no's. The evens always have 2 no's. If you pick the numbers I'm picking, negative 32. Okay, so 2 is the number that goes here. And then negative 2 is the number that goes here. And then yesterday's video specifically was cube root and square root, these two. So the yellow was yesterday's, and this one was yesterday's, and then the blue is today's. Okay, and the 7th root and the 6th root, they behave the same way. So you're going to do the same plan. Okay. Okay, so I want to graph both of these. So the evens will look like a certain shape from yesterday, but we'll talk about that later. And then the odds are going to look like another shape. Okay, so we'll answer that question right here, like what shape does it look like later. Okay, so let's graph these. The evens usually don't quite need as much space because you really don't need a left side because it says no. It's so strange that on the sides of my tablet, it won't let me do straight lines. So that's so interesting. I find it fascinating how this technology works. Okay, so here we go. So there's an even one. And then the odd one is really wide, usually. This one, we're not going to actually be able to graph all the values, but we want to still know where they are. Okay, so -1 is a no. So for -1, just put no. And that'll remind you not to graph in that section of the graph. If you don't put no, people continue the graph over to that section. Okay, 0, 0, 1, 1, 16, 2. Like, how in the world am I going to fit 16, 2 on the graph? So usually you're not able to fit 16, 2. So what I do, I'm going to write the words here. I'm going to aim for 16, 2. Okay, so I'm not going to go over to 16, but I'm not going to get up to 2 yet. So I'm just going to draw this little thing where it doesn't quite get to 2 because I'm not over to 16. So really you're graphing these 3 points, okay? These 3 points that I just highlighted, but 16, 2 isn't going to fit on your graph. So you're really only graphing 2 points and then aiming for 16, 2. And that's it. And then we'll move that one in a minute. Okay, we're going to move that one in a minute so you can see the movement, to remind you of the movement. Okay, now what letter did we call that one? You remember what letter we called it, either yesterday or before? Yeah, we called this one an R. Oops. So we called this one an R. R for radical or for root, but specifically it's the even ones. And then R and S are right next to each other in the alphabet, and the odds turn out to be an S. They don't quite look like that. They look like, they're like this. They look like a spread out S. And the R's have like a dot, and then they kind of just go to the right. And they don't go to the left. So that 0, 0 value, and then it goes to the right. Okay, so odds, -1, -1, 0, 0, 1, 1. Okay. 32, 2? I mean, I can't graph 32, 2. And if I graph 32, 2, like by saying by tens, how am I going to graph 1, 1? 1, 1's going to be too small. So what you do, we're going to write it over here. We're going to write aim for 32, 2. So try to think of where 32 would be, which is like way off the page, right? On your desk, like way over to the side. And that's what you're aiming for. So you're aiming for 32, 2. And that's actually like an R graph, right? So the right side of the S graph looks like the R graphs, but there is a left side of the odd graphs, and there is no left side for the even ones. And then you're going to aim over here for what? Aim for negative 32, negative 2. So way negative 32, negative 2. Okay, so that's going to just look like this. Now, technically, the way I drew this graph is okay, but technically the way it really looks is right at 0, it's vertical. So like you're doing a vertical right at that. So if you were climbing this mountain, it's really steep at the 0, 0 spot. So my graph does not look like a perfect one, but you don't have to draw a perfect one. You're just learning it. But it's actually really steep there. It's like impossible to climb practically because you're climbing just straight up vertically. Okay, but anyway, that's how it really looks. Okay, so let's move it. And then that's our lesson for today. So we're going to take the same graph that we just did. So let's do y equals, and this was what, the fourth root? So we're going to do the fourth root of x minus 3 minus 5. Yes, Charlize, on the homework, your numbers are that big because the numbers turn out to be that big when you have fourth roots and sixth roots. So for a sixth root, you end up with 64. So that's why you aim for it and you don't actually graph the dot. Okay, so that's why we need to know the shapes because we're really only graphing 2 points or 3 points, and then we're aiming for the other points. Okay. So the largeness of the numbers come from the problem, not from me making it up. So cube roots only go out to 8. So 8 we could graph. But anything past a cube root, fourth root, fifth root, sixth root, seventh root, I aim and I don't actually graph those dots. Okay, I do just what I did. So they kind of all look the same, except some are R's and some are S's. Okay, so for those of you who maybe didn't watch the video from before, just a reminder is if it's inside, it's opposite, and it's left and right. Remember, I was walking left and right inside the classroom. So this one is right 3, and this was outside the square root or outside the parenthesis, and outside was same. And remember, it was the stairs in the classroom, outside the classroom. And so it was the same, it was the stairs, it was up or down. So this would be down 5. Okay, so let's graph that. So I'm changing colors, and we need to go each dot. Now there's only 2 dots. So the shape of it is important to memorize. So we go over 3 squares, down 5. 1, 2, 3, 4, 5. Over 3 squares, down 1, 2, 3, 4, 5. And then you aim it. So don't make it go past, 2 squares, basically. You're making it really flat. And don't pass on the left, because remember, there's a no over here. Okay, and then that's your graph. And then what my plan to do on next week on Tuesday is the same topic, but we're going to do domain and range of these pictures because the domain and the range work very well for these pictures, and it's good practice. Okay, so let's do the one on the right. And then I know I graphed pretty fast, so can you guys say done when you're done with the graph on the left? Because I think I was too speedy. It's not showing me attendance. Oh, Dominic. Hey, Dominic. So Dominic, you're going to want to watch the video from the beginning and make sure you watch the video DL3 first. But you're welcome to stay just at the end here, but I wouldn't copy it down yet. So don't copy it down yet so you can see the rest of it. But I think the interaction, at least to see our last example, will help you understand it better when you go back and watch the video. So that's good. And I want to take a picture of the attendance today because I don't know why the attendance feature isn't showing up here on my Google Meet today. So let me take a picture of all your names so I can give you the 5 points for coming live. Let's see. Okay. Cool. I guess I get 10 points because I'm in twice. Just kidding. Anyway, so are you guys done? Done. Cool. Okay. So you got about another minute to copy that one down if you have it. I'm going to write the equation for the one on the right. We were doing fifth roots, right? And then seventh roots work like fifth roots. Sixth roots work like fourth roots, but they're a little bit different in their number choice. Okay, so let's say X, and then we'll just put plus 4. I think that'll be a good graph. Okay. Okay, so for this one, where's the 4? So where's the 4 on that one? Okay, so this one's outside. So which way would a 4 move it if it's outside? Yep, so up 4. Okay, so we're going to move each of these dots. Now I only have 3 dots. So I'm going to move each of my 3 dots up 4. 1, 2, 3, 4. 1, 2, 3, 4. And then I'm going to aim to not hit the 2 because I'm not supposed to go up to the 2 until I get 32 to the side. We're not graphing the 32 to the side. Okay, we're aiming for 32 to the side. And then the same thing here. So this is going to be like, you know, you'll see me when I graph it. I graph an R, and then I graph an upside down R. So it's kind of interesting. I'll graph the right side of it first, and then separately I graph the left side of it. I wonder if that's why mine look pretty good. I never noticed I did that before, but I just paused right there. So, and then it really looks like it's like vertical for a second. It's kind of hard to draw, but yeah, it's really hard to draw. Yeah, it's hard to draw with this little thing. But basically when you're drawing it, especially if you have a big graph, it kind of goes vertical for just a second and then comes back over here. Kind of looks like that. It's actually like a cubic on the side. We did cubics earlier in the year. We just saw a couple that look like this, but we didn't do too many of them. This is actually y equals x cubed or x to the 5th, but you'll learn that in algebra 2. And then this one is the cube root of x, or the cube root, the 5th root of x, or the 7th root, or whatever. Okay. So, and then we'll do a domain and range later. This is just kind of what the graphs look like. Okay, we'll do domain and range in DL5. I shouldn't have gotten you guys off track with my algebra 2 class, but I didn't want to post those 5 videos all separately, so that's why I kind of put them all together. Okay. So any questions on these graphs? So I want to spend 5 more minutes on this. So I'm going to show you just maybe not a whole graph, but I just want to show you some what you would do if it was bigger. Okay, so let's have the 9th root, but we will just make the table and describe, but we won't actually make the graph. So the 9th root of x plus 4 plus 3. Now I put it on the right side for a reason. Do you know why I put it on the right side and not the left side? I'll scroll down for those of you who came in late. What was my line? What was on the left side? Evens in the corner, and on the right side was odds in the corner. Exactly. So that's why I wrote it on the right side. So it is important where you're writing it. So on the right side of my line. Okay, so my parent would be the 9th root of x. And then which way would this one move? What do those two things do? Up 3, I agree. Left 4, I agree. Okay, now when you're making the table, is this one going to make an R or an S? Yes, so odd radicals make S's. And you'll forget that until you get to algebra 2, so it's not a big deal. But the movements and the tables of values and the plans are what's going to help you. Okay, and then -1, 0, 1. And what else? Okay, so the other thing that you pick is you pick 2 to the power in the corner. Always a 2. Okay, so you always pick 2. We'll put always for the 2. You always pick 2. You could put 3, but then your numbers are going to be bigger. So 2 is the best one to pick. Now, I don't know what 2 to the 9th is. I believe it's 5,012, but you would do that in the calculator. Okay, you wouldn't do that on your own. And then we would pick -512, not 5,000, 512. So the 9th root of -1, I need 9 lines to get -1. So what's the 9th root of -1? Is that impossible? Or is that an actual number? The 9th root of -1. Can an odd number of negatives give you a negative? Yes, so that's -1. And then what number multiplied by itself 9 times gives you 0? 0. 9 times by itself gives you 1. 9 times by itself gives you 512. We're like, we have no idea, except we designed it. We designed that number. So we know it's 2's. It's 2's because we're the ones who made it 2 to the 9th. So this is 2 here, and then this would be -2. And then we're going to put etc. Now, are you going to graph 512 too on your actual graph paper? Now, you're going to write it in your table, but are you going to actually graph it on the graph paper? 512, like where would that be on the graph paper? Now, if I decided to just go somewhere and call something 512, well, then I can't graph 1, 1. Okay, so you're going to graph those, and you're going to aim for the bottom ones. Okay, and let's just go left. Square root of x. Let's say square root of x minus 3. This would be left 3. Square root of x is your parent graph. You pick your same numbers, -1, 0, 1, 2 to the 2, because there's a 2 in the corner, an imaginary 2. That's 4. And then you also pick -4. And when you take the square root of -1, you get I. So that's a no. Now, and that's because even numbers of negatives can't be negative. Even negatives is a positive. So that doesn't work. So the evens always have a no in the -1 section, but you kind of want to see it happening. And then square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of -4, you're like, wait, don't I have the same problem? How can I have an even number of negatives give me a negative? It doesn't, it gives me a positive. So this is also a no. So if the top one's a no, the bottom one's a no. And then these are the ones you graph. And that's it. Now I'm going to leave this up, but I'm going to turn off the recording. Okay, I'm going to turn off the recording, and then you can catch up writing these last 2 examples down. Okay, and then you don't have to graph them. So let me just stop recording.